So the initial implementation of the circuit failed because apparently there's a different type of RGB LED that feeds the common cathode variant versus the common anode. Anyway, basically the instructions indicated to put that longer lead off of ground on the board, and instead I stuck it to plus 3.3 volts, and that fixed the wiring of the circuit. Some curiosities that came to me while wiring this particular circuit is because we often mock students or chide students for caring about wire color. But working through this example is kind of interesting because the wire color could really tell you something. For instance, the blue wire was connected to the blue LED, and the black was connected to the ground, so the colors did have meaning, and they can have meaning if a student assigns them so. But it's often not indicated that there's a reason that those wires are colored for some applications in the physics text, which I find kind of curious retrospectively. Anyway, the sample code seems to work just fine, working through all their different functions, and it was interesting wiring this circuit to see an implementation of using these bus bars, which I'd never bothered to use on a breadboard before. And seeing the layout that they had indicated on the sample circuit took a lot more space than what I might have used on a breadboard, but kind of made it more visually discernible. Also, the four legs of the LED were kind of difficult to display into place, but pulled them apart a little bit to get them sized more appropriately, and then ended up sticking the longer LED out a peg to make sure that they would all four have good settling space. Wiring the circuit, I was rather curious about the junctions of my breadboard. It seemed like they were kind of flaky, but my first thought was that I had a loose breadboard when the circuit didn't work as wired, but it turned out it just was referencing a different part than I had in my kit.